All right, today we're going to do dimensional analysis in circular motion. So what dimensional analysis means is that you're changing from one unit to another. That's all that really means. So if you're talking about like something travels like something travels 30 feet per second, and we want to figure out how many inches a minute it travels, we're going to change feet per second to inches a minute. So what we would do is we would do 30 feet for 1 second times, we want to go feet per minute, so we're going to go 60 seconds per 1 minute, and we're trying to change it to inches per minute, so we're going to go 12 inches per 1 foot. So remember that you have the same units cancel each other out if they're on the numerator and denominator. So I have feet here and feet here. Those are going to cancel. I have seconds here and seconds here. Those are going to cancel. So I'm going to be left with inches per minute. So I just go 30 times 60 times 12. So 30 times 60 is 1800 times 12. So I'm going to get 1 times 1 times 1 is just 1. So I'm going to get 21,600 inches per minute. And that's what we're doing when we're doing dimensional analysis. Linear speed, what you're doing when you're doing linear speed is if you think about a wheel and you have something right here on the wheel, this is going to rotate at the same speed as this point out here, but this piece is going to travel a lot farther than this piece right here, just because the circumference is a lot bigger. So when you're dealing with linear speed, you're actually talking about how far did this point move, or how far did this point move. And although they're traveling at the same rate, the distance that point A moves is a lot more. And the reason for that is because you're multiplying by the circumference. And this one has a lot larger, you're multiplying by the radius, and this one has a lot larger of a radius. So when we're doing this, this radius distance is what we're going to be multiplying by. So when we're looking at this, we're looking at linear speed, how far did point A move and how far did point B move. So if we say that this rotates at a revolution of, let's say 1 revolution, meaning this turns around in a circle 1 time per 30 minutes. 1 revolution over 30 minutes. And the point on the inside is at a distance of 20 feet. And the point on the outside is at a distance of 60 feet. The linear speed, we're going to go I want both of these to show up. Here we go. We're going to go 1 revolution over 30 minutes times 20 feet per 1 revolution. But this is only the radius, so to get the total circumference, I'm going to multiply that by 2 pi. And that's going to give me 40 pi feet per 30 minutes, or 4 pi over 3 feet per minute. The other one is 1 revolution for 30 minutes times 60 feet per 1 revolution times 2 pi. This is going to equal 120 pi per 30 minutes. Oops. Yeah, per 30 minutes equals 4 pi feet per minute. So you can tell that this one on the outside, point A, traveled 3 times as far. So that's what we're looking at when we're doing this stuff. We're looking at the fact that something on the outside of a circle or something farther out on the circle is going to travel farther than something on the inside of the circle. So that's what we're looking at when we're doing linear speed.